Okay, so once you have determined that your correlation coefficient, your R value, is significant, and you describe the relationship, then we're going to take it a step further. And this is where, when I talked about the line of best fit, that's where this comes in. So we're not going to worry about that part. A regression line is your line of best fit. But again, our calculators do an awesome thing for us, and they actually calculate it. So again, these are here if you really want to do it by hand, but you don't need to. All right, our calculator will do it for us. Here's how you have to write your line of best fit. Y prime, so you have to put a little like apostrophe with it, is equal to AX plus B. So A is your slope, B is your y-intercept. All right, again, we're going to just do that all right on our calculator, so we'll do that in just a second. Okay, marginal change is basically your slope. So this is how much the y value increases with an increase of 1 unit for the x value. And again, that doesn't make a lot of sense right now, but when we put it with some actual data, hopefully it'll make a little bit more sense. Okay, so when it asks about the marginal change, now your homework will not ask you about marginal change, but your test does. Okay, so we're going to put it in the notes, that way you have it. Okay, so it's your slope. These two I'm just going to talk about really quick, but we're not even going to write it down. Extrapolation, I always think it sounds like a bad word, but extrapolation is when you just like make a prediction. So here's what we know, therefore this is what we think. So I always think about this with gas prices. They will always say that they think the gas prices is going to increase by 20 cents this summer or whatever. So they take data that has happened in the past year to find a trend, and then they just say, this is what we think it's going to be. So that's extrapolation. It's not bad. It's just making a prediction for the future based on what we know right now. Okay. Influential points are just like your outliers. Just like you had outliers back in chapter 3, we can have outliers again. So we're not going to check for that or anything, but just so you know, that is in there. So what we're going to do is now, this is the same data that we just did. Okay, so we still have our cars and our revenue. So we calculated our R value, and we tested it and said, yes, it's significant. The relationship is that the more cars you have, the more revenue you're going to have. Okay, so what we're going to do then is we are going to, make the scatter plot, and so we're going a little bit backwards as far as making that, but we're going to make that first, and then we'll talk about the line of best fit. So for your scatter plot, again, we're going to put cars on the bottom, and it's very important to put in 10,000s. And this is revenue in billions. Right? So I'm going to count by tens. And sometimes I like to just put the little dashes in the middle so I know where the 5 marks are, but I don't have to write them in. And then I'll just count by ones. Okay, then we just dot our ordered pairs. So 63 is 7, 29 is 3.9, 20.8 is 2.1, 19.1 is 2.8, 13.4 is 1.4, and 8.5 is 1.5. So just looking at it, hopefully you can see that it looks like we should have a pretty good line that we could draw in there. Okay, And then we need a title, so I'm just going to put rental companies. All right. So now we want the equation of the regression line. So again, that's your y prime equals ax plus b. I'll write that over here. So if you go back to your calculator, when you do your stat calc linear regression, ax plus b, it's right in there. And again, it gives you the equation, and then it gives you your a and b. The only thing is you have to remember to put a little prime sign with your y. A and b need to be 3 decimals. All right, so our equation for this is going to be y prime equals 0.106x plus 0.396. That's it. There's your equation of your regression line. Again, that's only because we found that it was significant. If it wasn't significant, then we wouldn't even have to do that. All right. It says then we need to graph it on the scatter plot. We want to know what the marginal change is and what it means, and also predict the revenue of a car rental agency that has 200,000 automobiles. So we're actually going to do that part first. When you plot this on your line, you're not going to try to graph it like here's my y-intercept, here's my slope, and try to count it. You just need to find 2 ordered pairs. So the first ordered pair you want to find is what is for 200,000, because you already have to do that anyway. So y prime of, we can't put in 200,000, that would be way too much, so we would put in 20, because that's 20 10,000s. Okay, so again, you have to keep track of what the labels are. So 0.106 times 20 plus 3.96 gives us about 2.5. So here's where you don't have to round to 3 places. The only things that have to be rounded to 3 places are your A, your B, and your R value. Okay, so what this means is a rental company with 200,000 cars could expect a revenue of around $2.5 billion. Okay, so that's one line or one dot on our line that we're going to draw. Now we need to find another one. So that one is 20. You can pick anything you want. I'm going to pick something over here since there's such a wide open space. And I'm going to pick 50 just because it's kind of in the middle there. Again, you can pick anything you want. I just want to pick 50 because it's kind of open. So y prime of 50, 0.106 times 50 plus 0.396 gives us about 5.7. Okay, so when I graph these, 20 gives me 2.5, so it's going to be kind of hard because it's right in here. I put an X so that way I know which ones are dots and which ones are ones that I'm going to connect. And 50 is 5.7, so somewhere in here. If I had a ruler with me, I would use it, so I'm just going to do my best. There's my line of best fit drawn in there. Okay, so to find where your line goes, then you usually they'll ask you about a certain number, so there's one of your ordered pairs, and then you just need to pick another one. Okay. Last thing it wants to know is what is the marginal change and what does it mean. So again, from the front, your marginal change is just your slope, so 1.06 or 0.106. Well, what does that mean? It's more important that you know what it means, okay? It says that's how much your y value changes for every change in x value, okay? Every change of 1 unit. So here's what you have to realize. Our 1 unit on x is 10,000. So for every increase of 10,000 cars, a rental company could expect an increase of $0.106 billion. Now, $0.106 billion doesn't mean a whole lot to me, so I would probably change that to 106 million, just so it makes more sense, but that's what it means, okay? So for every increase of 1 unit on your X, which in our case was 10,000 cars, your Y, which was revenue, went up by 0.106 billion, all right, or which is 106 million, which makes a little bit more sense. Okay, so again, I'm going to go step by step. First, you can technically draw your scatter plot whenever in the directions in your homework it tells you to draw the scatter plot first. Calculate the R value, the correlation coefficient. Do your 5-step hypothesis test. If it's not significant, you stop. If it is significant, you need to describe the relationship, and then you will move on to do this. You will find the line of best fit or the regression line. You'll graph it, and then it will usually ask you some sort of questions about it as well. Okay, once you've done that, there's one more thing that we get to answer about these problems.